Hello, hope you're doing well. Just finished up with chapter 5.1 and 5.2 on the 5.3. Just go right through the book. 5.3, normal distributions, finding values, title of this unit or section. 5.3, we're going to look at finding an area given a z-score, but we're going to do the reverse. Okay, I call it working backwards. Finding a z-score given an area, and this is from chapter 5, section 3. So just a little review. Find an area given a z-score. What you're going to do is here's a z-score of 0 in the middle, z-score of 1, and a z-score of 2. Going to the left, we go -1 and -2. Well, one of the things we're going to do is find the area for a z-score. So I'm going to come up with a z-score here. Let's go if z is less than 1.2. So I'm going to stick with 1.2 for right now. If I got a z-score of 1.2, that gives me, here's 1, here's 2, right in between. About 1.2 is right in here, okay? So what I'm going to do is find not just that z-score, but I'm going to find an area left of 1.2. And I'm going to go to the table. So hopefully you bookmark the table in the back of the textbook. And appendix A16, A17, or again, you can Google this page. Just look for a standard normal distribution. Just Google that. So A16 are all negative z-scores. A17 are all positive z-scores. I'm going to look for a 1.2 in the table. And 1.20, I see 0.8849. So the area to the left of this, so 1.2 is right there. Area to the left of that, I'm going to shade in this area. Area to the left of 1.2, a z-score of 1.2 is 0.8849. And if we talk about a left tail area, that's called a percentile. If we talk about a right tail area, we just consider that an area or the probability of value is greater than a certain number. Again, if I use a P stands for probability with parentheses, the probability of an event occurring. So this is my event. And a lot of times it'll say less than or equal to. For right now, they kind of mean the same thing until we learn a little bit more. This is going to be 0.8849, again, the 88.49 percentile. So it's finding areas. Now we're going to talk about finding a z-score given an area. So we're going to work backwards. So if I say, find the 88th percentile. So the 88th percentile. Well, it's pretty close to 1.2. I already know that because this was 0.88. And I'm going to not put a percentage symbol next to it. I'm just going to write percentile. So 88th percentile or 0.88 would be the same thing. Find the z-score. Find the z-score that corresponds to the 88th percentile. I know it's going to be really close to 1.2, but I'm going to go into my table and I'm going to work backwards, working backwards. I'm going to go inside the table. I'm going to look for 0.8800. I know it's really, really close to 1.2. So I'm going to look for that number, and that'll give me a z-score. Okay, and this is going to be important for many reasons that I'll get to in a little bit. 0.8800. I see 0.8849. I need to get smaller. So I'm going to look at the row above and all the way to the right. 0.879, 0.8810. So I'm going to look in between there. So let me try to model this right here. I see 0.879. Zero. That's pretty close to 0.88. And I see 0.8810. So I'm going to look at these two numbers here. If I look all the way to the left, I see a z-score of right above 1.2. It's highlighted. I see 1.1. So the answer is not 1.1. I got to go to the top, and that'll give me a 100th percentile. So 0.0, right above 0.879 is 0.07. Right above this number is 0.08. So I'm thinking the 88th percentile is 1.17 or 1.18. You could estimate, I mean, you could use either one, really. But notice halfway in between those two numbers, our table doesn't show every single percentile. Our table shows 4 digits and nearest hundredth of a decimal place. So I'm going to use the number that's halfway in between. What's halfway between 1.17 and 1.18? That would be a z-score of 1.175. 75 is in between 70 and 80. Okay. I mean, if I was going to put a 0 there and a 0 there, I'm trying to find a number halfway in between. Okay. That's where a 0.88 would lie. So that would be a really accurate measurement of the z-score that corresponds to the 88th percentile. The 88th percentile is equal to a z-score of 1.175. Now, the book uses some notation. They use a capital P with a little number next to it, and you can find this in the book in the first example, or not in the first example, but the second example, example 2. They got a P and a little number next to it. So P88 just means the 88th percentile. Instead of writing it where it says write P88. So I'm going to go for a different number. I'm going to go for, let's go P90. P90 is a really important one. If you ever see P90, that is because we're looking for a number like the top 10%. The top 10%, I know it's not top, but it's right of 10%. So if I'm looking for the top 10%, let me show you on this graph right here. I'm going to put the area to the right over here is going to be 10%, 0.100. So the area over here is 10%. What z-score corresponds to the top 10%. And people use this all the time. They use the top 1%, the top 10%, especially talking about like test scores or GPA or ranking in a class. I'm in the top 10% of my class. So this is why percentile is useful. The top 10% is the 90th percentile because the area to the left is this area over here, 90%. So I'm going to look for 0.9000 inside my table. Again, go back to A18. I'm not looking for a z-score of 90 or 0.90. I'm looking for inside the table. And I took my pencil, and I put a box around this number. This number is really, really important. We're going to use it quite a bit in class as we progress. The 90th percentile is 0.8997. So we can't actually find the 90th percentile, but we can find 0.8997. That's the closest number to 90. And that gives us a z-score of 1.28. Again, we'll use that one quite a bit, a z-score of 1.28, especially when we get to confidence intervals and things like that. So it's working backwards. But wait, there's more. We got a calculator. All right, we could use it in the table or we could use it on the calculator. On the calculator, how are we going to do it? It's called inverse norm. Why inverse? Inverse, going in reverse, working backwards. Another way for us to say inverse. All right, so we got area, mean, and standard deviation, similar to a normal distribution, normal CDF, which we used previously. So what I'm going to do is find the area to the left. I'm going to go back to this first one. I'm going to do the 88th percentile. That should give me a z-score of 1.75. So I'm going to go to my calculator. I'm going to press on my calculator. It's second. That's the second button, and vars, VARS. Second vars to get the inverse norm, VARS. Second vars. Oh, there's normal CDF. Hey, number 2. We could do normal CDF, put a lower bound, upper bound, mean and standard deviation. In this case, we're going to do inverse norm. Right now, at this moment, we're just finding z-scores. So I'm going to use the mean and standard deviation as 0 and 1. So I'm going to do inverse norm 0.88. On my calculator, the mean of 0, standard deviation of 1. And again, these values we're going to use up here. So this has a 0 as the mean and standard deviation is 1 right there. The 88th percentile will correspond to that z-score, which should be pretty close to 1.75 or 1.175. Okay, this number right here is called the area. So if you have StatWizard, the area is 0.88. And then the mean is 0, standard deviation 1. It usually pops up by default. .1749. Well, that's using the book 1.1749. I mean, that's pretty close to 1.175. That's using the calculator. For the 88th percentile, we are concerned about the 90th percentile. We want to return a value of 1.28. So I'm going to go ahead and do that on a calculator. Inverse norm. And my inverse norm, I'm going to do 0.90, 0, and 1. So that'll give me a z-score of pretty close to 1.28. As you can see that it's going to be, this is not 0.90. So it's probably going to be a little bit more than 1.28, like 1.281. But using z-scores, usually we round to the nearest hundredth of a decimal place. So that's z-score given area in a nutshell. That'll get you through the first 2 examples. And I believe like the first, I assigned a few of the first few problems in the back of the textbook, but the homework, the first, 16 problems, they just give you areas, and then from those areas you find z-scores. Again, when it's capital P, like problem number 9 on page 257, P33. That means 33rd percentile. Find the z-score that corresponds to P33. Okay. In between areas, problem 21 and 22, just find the lower area or the upper area, one or the other. You don't have to find, well, you find both. One's negative, one's positive. But if you get the negative, like a z-score of negative 1.2, then the positive z-score has got to be positive 1.2. So that gets through just finding z-scores given areas. But there's another level to this. Okay, so that the next level to this would be finding areas or finding means and values given z-scores. Let me get rid of all this real quick. All right, so given a mean and standard deviation, I'm going to find an area, or given an area and a mean and standard deviation, I'm going to find a z-score. So let's talk about this for a second. So if I say I need an average and a standard deviation, so the average number of watchers of NFL game over a weekend, the average number of people that watch an NFL game is about 17 million, with a standard deviation of about 4 million. So I'm going to put on there the mean is 17 million. Standard deviation about 4 million. So I'm going to put that on my standard normal table. So you can see that 17 million, I'm going to put in the middle. These are in millions. 17, one deviation above, 21. I'm adding 4. 2 deviations above, add 4, I get 25, and go backwards. So I got 13 million. So on a weekend, how many people are watching an NFL game? So I would answer this question saying a couple percentiles. What represents the bottom 10% or the area to the left of 10%? So that's going to be over here, the 10th percentile. And we just looked up the 10th percentile. So that'd be this area. The 10th percentile. 10th percentile is negative 1.28, because the top 10% is positive 1.28. The lower 10th percentile is going to be negative 1.28. That's a negative z-score right over here. Actually, I should put it closer to 1. There we go. There we go. So negative 1.28. That would represent the bottom 10%. So how many viewers would that be? So I'm looking at a number right here, negative 1.28. What x value? This is x. This is z. So what x value is that? Again, we got to work backwards. So I got to go from a percentile, which is 10%, to a z-score, which I found is 1.28, to an x value, which is going to be between 9 and 13 million, probably closer to 13 million, probably about 12 million-ish, if I'm estimating properly. But I'm going to work backwards in my z-score formula. This is all done on page 254. So we go to page 254. If you're using a 7th or 6th or 5th edition, might be a little bit different page number, but they got the z-score formula, z equals x, which is one value minus the mean divided by standard deviation. We're going to find the x value. This is considered x value right here. So I'm going to solve for x, multiply by standard deviation and add the mean. And you'll see that formula. They call it the x. I call it the x formula. That's the mean plus z-score times standard deviation. And again, in the textbook, they show you how to get this x value. I'm finding x. Okay, so sometimes it'll say find x. So the mean is given. The mean was 17 million. So I'm gonna plug in 17 for x for mu. Z-score, what z-score corresponds to 10th percentile? That's negative 1.28. So I'm gonna plug in negative 1.28 there for z. And then I have to substitute one more thing, standard deviation, which is about 4 million. That'll give me how many people represent the 10th percentile. I'm going to do 17, 1.28 times 4. 11.88. Ooh, just like I mentioned. It is really close to 12. 12 was an estimate. So 11.88. And this is again in millions of viewers. If you're a big NFL fanatic, I just looked up the 2021 results. 11.88 million represents the 10th percentile. So that number is here. What number represents let's go for the 30th percentile. So again, I'm going to have to go to P30, go into the back of my table. This is a new z-score. P30, I'm going to look inside the table. I'm not looking at z-scores. I'm looking inside the table for 0.300. And I got a number really close to that, negative 0.53. So z equals negative 0.53. It might be a number in between 0.52 and 0.53. So I'm going to be a little more accurate here. I'm going to go to the nearest thousandths of the decimal place. That's kind of like the one we did earlier where it's in between two numbers. So again, I'm going to use the X formula, and I'll plug in X. Mu is 17, negative 0.525 times 4. Substitution. So I'm looking for right in here, halfway between 0 and -1. Well, halfway between 13 and 17. It's about 15 million. Let's see. I'm going to replace 1.28 with 0.525. 14.9. There you go. Like I said, really, really close to 15. 14.9. What population of viewers represents the top 10%? So again, I'm thinking over here, that's between 21 and 25 million. The top 10%, I would calculate the 90th percentile. I would use a z-score of positive 1.28, represents the 90th percentile. 1.28 times 4 plus 17. I'm going to change the negative to a plus. 22.5. I got 22.12. 22 million. That's the top 10%. Calculator. I move the inverse norm, area, mean, and standard deviation up here. Oh, we're given a mean and standard deviation. What is the area? So I could do both of these calculations with inverse norm on my calculator as well. I could bypass having to look up these numbers in the table. I go straight to the calculator. Inverse norm, the area is, this represents a z-score of negative 1.28. Remember that was the 10th percentile. 0.1. You don't have to put a 0, but you can. The mean is 17. Standard deviation is 4. Inverse norm, 0.1, 17, 4. We should get a value really, really close to 11.88. And the 30th percentile, the calculator obviously is going to be a little bit more accurate than what we found because we're doing this by hand. You do it on the calculator. Inverse norm, 0.30. The mean is 17. Standard deviation is 4. Mean and standard deviation will always be given for these inverse calculations. And we should get about 14.9. Again, a little bit more accuracy with that value. All right, thank you.